Morning, ma'am. My name is Harshvardhan from Environment Department of A section. Today, my topic is about live virtual mission migration, survey research challenges, and future directions. Coming to introduction part, cloud computing relies heavily on virtualizations, where multiple virtual missions run on a single physical server. In modern data centers, there is a need to perform server maintenance, balance the workload, reduce energy consumptions, avoid downtime. Live virtual machine migration enables moving a running VM from one physical host to another without shutting it down and with a minimal service interruption. So, first, what is live virtual machine migration? Live virtual machine migration is the process of transforming VM memory, CPU state, storage state, network connections from a source host to a destination lost while the VM continues running. Its key goal is to zero to no, near zero downtime. So, why live VM migration matters in cloud compute? Its major users are just like a load balancing, hardware maintenance, energy efficient consolidation, fault tolerance, high availability. Without live migration, services would need to stop affecting users. Optimizing resource utilization. Cloud data centers frequently underutilize approximately 30% of their servers, leading to significant energy waste and increased operational cost. Live VM migration directly addresses this by enabling dynamic workload shifting. Seamless workload shifting. This technology allows for the movement of effective workloads between physical machines without any service interruptions, ensuring continuous operation and maximum efficiency. And are foundational for modern clouds. Live VM migration is crucial for maintaining optimal load balancing, ensuring fault tolerance, facilitating maintenance tasks, and significantly improving energy efficiency in contemporary cloud infrastructure. So, as we know what is live VM migration, live VM migration is a sophisticated process that involves moving a running virtual machine from one physical host to another without any perceptual interruption to the services it provides. This ensures that users experience continuous availability and connectivity even during infrastructure changes. Unlike non-live migration, which requires pausing the virtual machine's operations during the transfer, live migration is designed to be seamless. This capability is paramount for applications demanding high availability and for cloud environments where downtime is simply not an option. It is the cornerstone of Agile cloud management, enabling resource reallocation, system upgrades, and fault recovery without impacting end users. Coming to core techniques of live VM migrations, there are pre-copy migration, post-copy migration, and hybrid approaches. Pre-copy migration includes the involves and iteratively copying the VM's memory pages to the destination host while the source VM continues to run. A final synchronization phase with minimal downtime transform any remaining changes pages. Under post-copy migration, in contrast, post-copy migration starts the VM on the destination host almost immediately. Memory pages are then fetched on demand from source, significantly reducing the initial migration time. Hybrid approaches. Hybrid approach combines the element of both pre-copy and post-copy techniques. This allows for a flexible balance between minimizing downtime, managing network load, and adapting to specific workload characteristics. And there are also different types of virtual machine migrations, just like cloud migration, live migration. Under cloud migration, the VM is powered off state is transferred, VM restarts at destination. It does not cause downtime. And under live migration, VM keeps running. States transfer dynamically. Users experience a minimal interruptions. Preferred in a cloud environment. And also, the pre-copy migration works as it copies all memory pages while VM is running, and also tracks modified pages and recopy dirty pages in multiple rounds, briefly pause the VM, and copy remaining pages and CPU state. Its advantages are low downtime, widely used, and its limitations are it is high network usage, repeated copying of dirty pages, and the post copy migration. It works as suspended VM, transfer minimal CPU state, resume VM at a destination, memory pages fetched on demand. And its advantages are no redundant memory copying, lower total data transfer, and its limitations are the page fault degrade performance, risky if network fails. And the hybrid migration combines pre-copy plus post-copy, reduces the page faults and redundancy, more complex implementations. Key performance matrices and challenges. There are total downtime. Downtime is nothing but the time VM is paused. Migration time, total transform duration. Data transform is nothing is under network overhead. Application performance, impact on running services, energy consumptions, power use during migration. Under downtime minimization, the primary goal is to ensure downtime is as close to zero as possible, preventing any service disruptions for end users. Even milliseconds can be critical for certain applications. Under total migration duration, the overall time taken for a migration impacts the availability of resources and places a load on the network infrastructure. Faster times mean faster resource release and less network congestion. Under energy consumptions, the migration process itself consumes power. Balancing the benefits of consolidation within the energy cost of migration is a key consideration for achieving green computing objectives. Network load management. High bandwidth consumptions during migration can degrade the performance of other active services on the network. Migration protocols are essential for mitigating. Storage and also the storage and network considerations. The storage migration is shared storage is easier. Non-shared storage requires a disk copy. Under a network state, IP address preservation, so TCP connection continuity, software-defined networking support. And under research challenges in live VM migration, there are different research challenges like high network overhead, which has a large memory size and limited bandwidth, and it has a dirty page rate. Right, intensive workloads cause repeated copying, performance degradation, CPU and input-output contamination during migration, security and privacy, VM state exposed during transfer, man in the middle attacks, failure handling, network failure during the migration, incomplete state transfer, heterogeneous hardware, CPU architecture difference, device and compatibility, and also wide area network migration, managing migration across a geographically disparate data centers with a varying latency and bandwidth constraints presents significantly hurdles for maintaining performance and reliability. And our concurrent VM migration, migrating multiple virtual missions simultaneously without causing performance degradation or resource contentions on shared infrastructure is a complex optimization problem under SLA compliance under load, ensuring that service level agreements are met even when migrations occur under heavy system workloads, requires advanced predictive and adaptive techniques under balancing trade-offs, achieving an optimal balance between migration speed, efficient resource utilizations, and consistent applications performance remains a continuous area of research and development. And coming to next part, earning solutions and AI integration. Under this, there are AI-driven migration decisions, energy-aware migrations, secure migration protocol, containers and micro VM migration, edge and fog computing. AI-driven Under AI-driven migration decisions, it predict to optimal migration timing, reduce unnecessary migrations. Under energy-aware migration, minimize power consumptions, and green cloud computing. Under secure migration protocols, with encrypted memory transfer, trusted execution environments. Under container micro VM migrations, lightweight alternatives to VMs, faster live migrations. Under edge and fog computing, mobility aware migrations and low latency requirements. And also, under AI-driven strategies, artificial intelligence is being leveraged for advanced load balancing and developing energy-aware migration strategies, leading to significant improvements in operational efficiency. Predictive analytics. By employing predictive analytics, cloud systems can proactively schedule migrations. This reduces the impact during peak load periods and enhance this reduces the impact during peak load periods and enhances overall system stability. Container-based migrations. The adoption of containerization is driving new advancements in live migration. Container-based approaches offer lightweight and notable faster transition, opening new possibility for microservices architecture. Coming to real-world impact and case studies, uh, cloud provider uptime. Tech gains like Google and Amazon nothingly utilizes live migration to maintain the uptime of their vast cloud services, particularly during essential hardware upgrades and maintenance windows, ensuring continuous availability for millions of users. In efficiency energy reductions, there multiple studies have demonstrated that the strategy applications of live migration can reduce data center energy consumptions by as much as 20%. This is achieved through dynamic consolidation of workloads onto fewer physical servers, leading to sustainable environments and cost and benefit. WAN challenges persist. Despite significant advancements, challenges in wide area network migration scenarios continue to be a key driver for ongoing research and innovation. This area focuses on overcoming latency and bandwidth limitations to enable seamless cross continuations migrations. Coming to future directions in live VM migration, heterogeneous cloud environment, the future developments will focus on enhancing support for diverse cloud environments, including seamless integration with edge computing, ensuring flexibility across varied infrastructures. Under 5G and ultra-low latency, integration with 5G networks and beyond will enable ultra-low latency migrations crucial for real-time applications and services requiring instantaneous data transfer. Under standardized framework, the development of a standardized framework for cross-cloud and multi-cloud live migration will simplify management and foster greater interoperability across the different providers. Under enhanced security and privacy, increased focus on robust security protocols and privacy preserving mechanisms during migration processes will be paramount to protect sensitive data in transit. And coming to conclusion part towards seamless, efficient cloud operations, pivotal for resilience, unlocking potential, driving innovation, smarter, greener ecosystems. Under pivotal for resilience, live VM migration is indispensable for building flexible and resilient cloud infrastructures, forming the backbone of modern digital ecosystems. Under unlocking potentials, overcoming the remaining technical challenges will unlock unprecedented levels of scalability and sustainability within cloud operations. Under driving innovations, continued research and innovative advancements will propel the next generation of cloud computing forward, leading to more dynamic and efficient systems. Smarter, greener ecosystems. Embracing these advancements allow us to construct a smarter, greener, and more reliable digital environment for future demands. Thank you.